Just like Jodie Foster's character in the movie Contact, scientists have come across a mysterious signal from a galaxy far, far away.
NASA astronomers have discovered the most distant black hole yet seen.
A black hole is a region of the universe that it has such strong gravity, where the gravity is so strong that nothing, not even light, can escape.
Space, the final frontier, right? Well, along with breathtaking beauty and endless curiosity, space holds some genuine chills. We're talking cosmic horrors so real, they'd make your skin crawl. But hey, that's the price of cosmic exploration, right? So what are some of the unsettling wonders of the cosmos? Solar sandstorm. Imagine there's a hurricane, but instead of rain and wind, it hurls scorching hot million-degree particles. That's a solar sandstorm, a colossal eruption on the sun's surface that flings superheated material out into space. Unlike anything on Earth, these solar tempests can travel vast distances and disrupt our entire planet's technology. But what makes these fiery outbursts so strange? They erupt from the sun's corona, a scorching region hundreds of times hotter than the sun's surface itself. How can something so hot originate from a cooler layer? Astronomers are still piecing together this mysterious puzzle. Galactic cannibalism. Galaxies, those swirling islands of stars, dust, and gas, might seem like majestic loners, gracefully waltzing through the cosmos. But the universe can be a rough neighborhood, and galaxies sometimes have a taste for their smaller brethren. This is galactic cannibalism, a slow-motion celestial brawl where a larger galaxy engulfs a smaller one. Think of it as a cosmic David and Goliath face-off, but instead of slingshots, gravity does the dirty work. The culprit? The immense gravitational pull of the larger galaxy. As it drifts through space, its gravity tugs on the smaller one, like an invisible hand reaching out and grabbing. Over vast stretches of time, this relentless pull distorts the smaller galaxy, stretching its spiral arms and pulling its stars outward. But the thing is, galactic cannibalism isn't a clean sweep. It's a messy affair. The smaller galaxy doesn't just disappear. Instead, it gets shredded, its stars scattered into chaotic orbits around the larger one. The leftover gas and dust gets swallowed whole, fueling the cannibal star formation. The resulting galaxy becomes a misshapen mess, showing how violent its past was. This galactic carnage isn't just a theoretical nightmare. Evidence is plenty. Astronomers have observed countless galaxies with warped shapes and lopsided structures, suggesting a history of cosmic snacking. Even our own Milky Way galaxy is likely a cannibal, having devoured smaller galaxies in its past and destined to merge with the neighboring Andromeda galaxy billions of years from now. But galactic cannibalism raises a host of questions. Does this feasting frenzy affect the evolution of galaxies? Do the digested stars retain any unique properties within the larger galaxy? And perhaps most intriguing, could this cosmic carnage influence the potential for life within these galactic giants? The messy dance of galactic cannibalism might hold the key to understanding the grand narrative of galaxy formation and evolution, rewriting the story of how these majestic structures came to be. White holes. We all know about black holes, stellar vacuums, swallowing everything that gets too close. But what if the universe had cosmic fountains instead? Let us introduce you to white holes, theorized anomalies in space-time. Unlike black holes, nothing can enter a white hole. It only spews out matter and energy in all directions. Here's the mind-bender. Based on our current understanding of physics, white holes shouldn't exist. They violate the well-established law of entropy, which states disorder or randomness always increases in a closed system. So are white holes a tear in the fabric of our known physics, or a cosmic mirage yet to be explained? We might have to wait a little longer for that answer. Venus is dangerous. Venus, Earth's closest planetary neighbor, often gets called our twin, but beneath its seemingly serene, cloud-covered surface lies a nightmarish reality. Venus is a world of extremes, a testament to a cosmic wrong turn that makes it the most dangerous planet in our solar system. The first shocker? Temperature. Forget balmy. The Venusian surface bakes at a scorching 460 degrees Celsius, or 860 degrees Fahrenheit, hot enough to melt lead. This infernal heat is thanks to a runaway greenhouse effect. Thick clouds of toxic carbon dioxide trap the sun's rays, turning Venus into a cosmic pressure cooker. Speaking of pressure, the Venusian atmosphere is 90 times denser than Earth's, akin to being crushed under a kilometer of ocean. Sending probes to Venus is a suicidal mission. They're crushed and cooked within minutes. Here's the real kicker: rain, but not the kind that nourishes life. On Venus, it rains sulfuric acid. These superheated droplets eat through the rock and metal with ease. Imagine an acid storm permanently raging across the entire planet. So what went wrong? Venus and Earth started out similar, but a runaway greenhouse effect turned Venus into a toxic wasteland. The question that haunts scientists: could this be a glimpse into Earth's future? Did Venus suffer a tipping point, a drastic shift in its atmosphere that Earth could one day experience? Understanding Venus's hellish state might hold the key to safeguarding our own blue marble. But for now, Venus serves as a stark reminder of the delicate balance that allows life to thrive, and the unforgiving nature of a universe that can turn seemingly benign planets into cosmic infernos. The dark flow. Galaxies clump together, influenced by gravity, but the grand dance gets a mysterious twist with the dark flow. This large-scale motion pulls entire clusters in a specific direction, a cosmic current unseen and unexplained by the known distribution of matter. It's like an invisible hand stirring the galactic soup, defying our understanding of gravity on a grand scale. Current maps of the universe, meticulously crafted from observable matter, leave a gaping hole. The source of the dark flow remains stubbornly hidden. Is it a monstrous structure lurking just beyond the edge of what we can see, exerting its gravitational pull? Or is it something even more mind-boggling, a crack in our current understanding of physics, hinting at forces yet to be discovered? Floating space corpses. Astronauts dream of pristine, silent voyages. Reality might hold something more unsettling. Our spacefaring history is littered with debris, discarded rocket parts, dead satellites, and the haunting possibility: floating space corpses. Cosmonauts from the Soviet Soyuz 11 mission are suspected to be among them. The weird part? Space is a fantastic preservative. The harsh vacuum desiccates bodies, essentially mummifying them. Radiation might blacken skin and bones, but these celestial corpses could drift for millions of years. Orbiting Earth at thousands of kilometers per hour, they become ghastly reminders of our mortality and the potential dangers lurking in the seemingly serene expanse of space. Are these the only such casualties? Or are there more silent voyagers out there, unknown and unseen? Rogue planets, lone wanderers of the cosmos. Rogue planets roam the galaxy unattached to any star system. Unlike our own planets, tethered to the sun by gravity's leash, these cosmic nomads forge their own paths. Some might be ejected from their stellar nurseries during violent gravitational encounters. Others, perhaps, condense from swirling gas clouds that never quite manage to ignite into stars. Here's the crazy part. Our current understanding suggests rogue planets should be rare. Yet, recent discoveries hint at a surprisingly high number of these lonely giants, lurking unseen in the darkness. Are rogue planets more abundant than previously thought? Or are they a sign that our theories of solar system formation need revision? The vast emptiness may be teeming with these cosmic ghosts, silently rewriting our understanding of planetary populations. Loose skin falls off in space. Astronauts prepare for the extraordinary in space. But what about the strange side effects? Here's one you might not expect: shedding skin in space. During long missions, astronauts experience a weird phenomenon. Loose skin, particularly around the face, neck, and shoulders, starts to bubble and detach. It's not like molting a lizard suit, but the lack of gravity weakens the usual pressure on the body. Fluids redistribute, and skin cells weaken. The weird part? This isn't just dead skin. It can include living cells. Our bodies are constantly renewing skin, and space disrupts this delicate balance. So is this a harmless side effect, or does it indicate something more concerning about human health in zero gravity? More research is needed, but one thing's for sure: space travel throws some unexpected curveballs at the human body. No sound in space. Silence. An unsettling, all-encompassing silence. That's the reality of space, a truth often overshadowed by the awe-inspiring visuals of distant galaxies and nebula. But why the eerie quiet? Sound on Earth travels through vibrations. Air molecules bump into each other, carrying the energy of your shout or a song across the distance. But space is a near vacuum, devoid of these molecular messengers. There's nothing for sound waves to cling to, nowhere for them to travel. So your desperate scream in the inky blackness would go unheard, a lonely ripple in the fabric of existence with no audience. This profound silence isn't just unsettling, it raises a whole host of questions. If we can't hear anything in space, how do we study the violent collisions of stars or the explosive birth of galaxies? Do these cosmic events unfold in complete silence? Or are there undiscovered energy waves carrying information we haven't yet learned to perceive? Astronomers rely on a different kind of listening, sophisticated instruments that translate electromagnetic waves, light for instance, into soundscapes that allow us to grasp the universe's hidden music. But is this just a human attempt to impose meaning on the void? Or is there a deeper truth waiting to be decoded from the silence itself? The Big Crunch. Our universe is ever expanding, right? Galaxies hurtle further apart, carried by the invisible force of inflation. But what if this isn't the whole story? Here enters the Big Crunch, a chilling theory for the ultimate fate of the cosmos. It proposes a reversal, a cosmic rewind where expansion grinds to a halt, then collapses in on itself. Imagine the entire universe, everything from the faintest starlight to the densest black hole, squeezed back into a single, infinitely dense point. Weird? Absolutely. Here's why it gets stranger. Gravity, the invisible architect of the universe, is the culprit behind both the Big Bang and the Big Crunch. The same force that flung everything outwards would eventually become strong enough to pull it all back in. But according to our current understanding, there isn't enough gravity to achieve this grand reversal. Recent observations suggest the universe might be expanding even faster than expected, fueled by a mysterious dark energy. So, is the Big Crunch a cosmic dead end, or is there something we're missing in our understanding of gravity? The Big Crunch paints a picture of a universe not infinite, but cyclical. Could our cosmos be a cosmic yo-yo, eternally oscillating between Big Bang and Big Crunch? Or perhaps the collapse wouldn't lead back to a singular point, but trigger a big bounce, a new universe erupting from the ashes of the old. What do you think? Rogue black holes. In your mind, picture a black hole, a cosmic glutton with an insatiable appetite, forever devouring anything that strays too close. Now picture the opposite, a black hole adrift, unattached to any star or galaxy, silently roaming the vast emptiness of space. These are rogue black holes. Loners of the cosmos, in their existence challenges our understanding of stellar evolution. For a black hole to be born, a massive star needs to die a violent death. The star's core collapses under its own gravity, crushing protons and neutrons together until a point of singularity forms, a region of infinite density and gravity from which nothing, not even light, can escape. But how can a black hole become a rogue? Well, the prevailing theory suggests they might be the chaotic afterbirth of a colossal star system mosh pit. Next, picture a swirling dance of supermassive stars, locked in a gravitational embrace. As these giants pirouette around a common center, some might collide in a cataclysmic event. The resulting merger could birth a supermassive black hole. But the violence of the encounter wouldn't always be symmetrical. The recoil from the collision might fling the newborn black hole out at tremendous speeds, severing its ties to the stellar system and sending it hurtling into the unknown. Another theory proposes that rogue black holes might be shy remnants of a bygone era. In the early universe, when galaxies were just forming, conditions might have been conducive to the creation of black holes without the need for a giant star's death it throws. These primordial black holes could be lurking unseen throughout the cosmos. But here's the real kicker. Astronomers estimate there could be millions, even billions of rogue black holes out there. silently stalking the cosmic planes. The trouble is they're almost impossible to detect directly. They don't emit any light or radiation, and their immense gravity only betrays their presence if they interact with nearby matter. So, are rogue black holes cosmic ghosts haunting the universe? Or a missing piece in our understanding of black hole formation? With every new discovery, astronomers are getting closer to unraveling the mysteries of these lonely giants. Unexpected meteors. We all know about meteors, those blazing streaks of light that streak across the night sky. But space throws occasional curveballs, unleashing unexpected meteors that defy our predictions. These celestial surprises come in two flavors, and both challenge our understanding of the solar system. The first kind of unexpected meteor is the solo act. Most meteors belong to meteor showers, streams of debris left behind by comets. These predictable displays pepper the night sky at specific times of year. But sometimes a lone meteor streaks across the sky, seemingly out of nowhere. These rogue meteors could be fragments from long-dead comets or collisions between asteroids. But what's the problem? Well, they're difficult to trace back to their origin, leaving a trail of unanswered questions. Are they leftovers from our solar system's chaotic past? Or do they hint at undiscovered celestial bodies lurking in the dark corners of space? The second type of surprise meteor shower is the outburst. Outbursts are unexpected bursts of meteoric activity, far exceeding the usual rates of a known shower. These sudden deluges can blanket the sky with hundreds of meteors per hour, catching astronomers and stargazers off guard. What exactly causes this? The Earth could be plowing through a denser than expected cloud of debris left behind by a comet. Or the comet itself might be unexpectedly shedding more material than anticipated. These outbursts highlight the dynamic nature of these cosmic dust trails and the possibility of hidden pockets of dense material waiting to unleash a celestial light show. Unexpected meteors are a cosmic reminder that the night sky holds more than meets the eye. They challenge our understanding of the solar system's debris field and raise questions about the origins of these celestial wanderers. So the next time you gaze upwards, remember that shooting star could be part of a well-orchestrated show or a lone wolf blazing a trail through the darkness. Will future advancements allow us to predict these celestial surprises? Or will the universe continue to throw us unexpected meteors, keeping the night sky a place of wonder and discovery? Type Lax supernova. Supernova, the explosive deaths of massive stars. These celestial fireworks are a cornerstone of stellar evolution. But the universe loves to play with our expectations, and Type IX supernova are a prime example. Unlike their kin, these stellar send-offs are dimmer and less violent, defying our understanding of how stars die. The norm is that a heavyweight star nearing the end of its life fuses heavier and heavier elements in its core. When it can no longer sustain this fusion furnace, the core collapses under its own gravity, triggering a colossal explosion that throws the star's guts across the cosmos. This is the recipe for a typical supernova, a brilliant display of light and destruction. Now we've got the Type IX supernova. These faint cousins exhibit a much weaker explosion, ejecting far less material. Their luminosity is like a flickering candle compared to a raging inferno. Here's the weird part. Unlike their Type Ia brethren, which completely obliterate the progenitor star, Type IAX supernovae seem to leave a survivor, a zombie star remnant. The prevailing theory suggests Type IX supernovae originate in binary star systems. One star, a white dwarf, the collapsed core of a once ordinary star, siphons off material from its larger companion. As the white dwarf nears a critical mass, it should ignite in a full-blown Type Ia supernova. But with Type IX, something goes awry. The ignition might be incomplete, or the white dwarf sheds some of its mass before reaching the tipping point, resulting in a fizzle rather than a bang. The existence of a zombie star remnant further complicates the picture. How can a star cheat death, even partially? Are Type IX supernovae a distinct evolutionary pathway for white dwarfs, or a glitch in our current understanding of stellar explosions? Space has a smell. Space may be the final frontier, but according to astronauts, it doesn't exactly smell like roses. While the vast emptiness offers stunning visuals, returning astronauts report a surprisingly distinct odor, the smell of space. This is odd because space, by definition, is a vacuum, devoid of the molecules that carry scents on Earth. So what's causing this phantom aroma? The key might lie in the interaction between spacesuits and the harsh environment of space. Micrometeoroids and solar radiation bombard astronaut suits, breaking down outer materials and off-gassing trapped molecules. This breakdown could explain the metallic or burnt plastic smells some astronauts describe. Another theory points to a more fundamental change. Atomic oxygen, a byproduct of ultraviolet radiation splitting oxygen molecules, might cling to the suit's material. When astronauts return to Earth and the airlock repressurizes, this atomic oxygen combines with regular oxygen molecules to form ozone, a gas with a sharp metallic odor. This could explain the chemical or burnt electrical smells reported by some. The weirdest part? These smells aren't just a quirk. They might have practical applications. Astronauts train in chambers filled with these synthetic space smells to prepare for situations where a suit might be breached. The distinct odor could serve as a vital warning, alerting astronauts to a tear or malfunction before a more serious situation arises. So space may be silent and dark, but it might not be entirely odorless. But are these smells just a byproduct of human interaction? Or a hint of something more? A property of space itself waiting to be revealed? That's a scary thought, isn't it? Vampire stars. Forget Count Dracula. Space has its own brand of bloodsuckers, vampire stars. These aren't celestial undead, but rather a class of binary star systems with a dark secret. They appear ordinary at first glance, but a closer look reveals a disturbing reality. One star slowly siphons the life out of its companion. A typical vampire star system consists of two stars, a hot, bright B-type star, and a cooler, less massive companion. Here's the vampiric twist. The B-type star, fueled by its immense size, burns hydrogen at a ferocious rate. But it doesn't burn alone. The B-star's powerful gravity stretches and distorts the companion, pulling in a steady stream of gas. This stolen material spirals inwards, feeding the B-star's furnace and accelerating its burn rate. This stellar robbery doesn't happen neatly. The stolen gas doesn't fall directly onto the B-star's surface. Instead, it forms a swirling disk around the B-star, a cosmic feeding frenzy. This disk becomes a breeding ground for strange phenomena. Powerful winds whip through it, flinging stolen material back into space, while the B-star's intense radiation ionizes the gas, creating a glowing halo. The effects on the victim star are brutal. As the B-star gorges itself, its companion withers away, stripped of its outer layers and shrinking to a fraction of its original size. Vampire stars pose a challenge to our understanding of binary star evolution. How does this constant theft affect the lifespan of both stars? Do these stolen materials alter the B-star's composition, leading to a unique stellar demise? And perhaps most intriguing, could vampire stars play a role in the birth of rare and exotic objects like Wolf-Rayet stars, known for their powerful winds and unusual compositions? The coldest place in the universe. The coldest known spot in the universe is a cosmic deep freeze, the Boomerang Nebula. Nestled 5,000 light-years away, this wispy cloud of gas and dust holds a temperature that defies expectations. A bone-chilling 1 degree Kelvin, a hair above absolute zero. That's colder than the depths of space itself, and about minus 272 degrees Celsius, frigid enough to solidify almost anything. Now, the Boomerang Nebula isn't some exotic object. It's a planetary nebula, the cast-off shell of a dying star. As a sun-like star nears its end, it throws off its outer layers, creating a glowing shroud. But the Boomerang Nebula is much, much colder than expected for this type of object. The most popular theory suggests the Boomerang Nebula's unusual chill stems from its violent past. The dying star at its center might have ejected its outer shell in a lopsided explosion, creating a fast-moving, thin cloud that rapidly radiates away heat. But this doesn't explain everything. Why is the Boomerang Nebula so much colder than other planetary nebulae? Are there undiscovered factors at play, properties of stellar death we haven't yet considered? Lunar exit. Think of a cosmic one-way street. That's the lunar exit, a theoretical breach in the fabric of space-time, spewing matter and energy out from the moon's surface. Here's the mind-bender. According to our current understanding of physics, lunar exits shouldn't exist. Unlike black holes, which gobble up everything that gets too close, a lunar exit lets nothing in, only out. The concept originated in fringe science, but some physicists have explored it as a hypothetical explanation for unusual lunar phenomena. Some reports claim sightings of strange lights or gases erupting from the moon's surface. These anomalies could be explained by known lunar processes like volcanic outgassing. But could they be a hint of something more exotic? A lunar exit spewing forth unknown materials? The lack of concrete evidence makes lunar exits highly speculative. Great Red Spot. The Great Red Spot is a swirling enigma on Jupiter, a colossal storm unlike anything on Earth. Spanning a width greater than Earth itself, this anticyclonic behemoth has raged for centuries, baffling scientists with its longevity and resilience. What's weird is that unlike Earth's hurricanes that fizzle out in a week or two, the Great Red Spot has been churning for at least 350 years, possibly much longer. Early astronomers might have even spotted it in the 1600s. What keeps this going? One theory suggests the Great Red Spot thrives because of Jupiter's unique atmosphere. Unlike our layered atmosphere, Jupiter's atmosphere is a swirling soup of gas and liquids. The high-pressure environment within the Great Red Spot might be constantly churning, creating a self-perpetuating storm system. Another theory points to Jupiter's powerful jet streams. The Great Red Spot sits nestled between these fast-moving atmospheric currents, like a cork in a swirling rapids. These jet streams might be channeling energy into the storm, keeping it from dissipating. But the mystery deepens. Recent observations show the Great Red Spot shrinking. Is this a sign of the storm finally weakening? Or is it morphing, changing its shape and behavior in ways we don't yet understand? HD 189773b. HD 189773b, a stranger in the constellation Vulpecula, isn't your typical planet. It's a scorching hot Jupiter, a gas giant whipped by ferocious winds and bathed in the relentless glare of its parent star. But that's not all that makes this alien world so weird. Here's the first oddity. Proximity. HD 189773b orbits its star incredibly close, just 3% the distance between Earth and our Sun. This tight hug subjects the planet to an infernal heat, a scorching 4,600 degrees Celsius or 8,630 degrees Fahrenheit, hot enough to melt glass. The weirdness continues with the atmosphere. Unlike the swirling gases of Jupiter, HD 189773b's atmosphere is dominated by vaporized silicates, the building blocks of glass. But that's not all. Recent studies suggest the atmosphere might harbor traces of water vapor. The wow signal. In the vast cosmic ocean of radio chatter, one signal stands out: the wow signal. Detected in 1977 by Jerry Ammon, an astronomer working on the Search for Extraterrestrial Intelligence project, it sent shivers down the spines of scientists. Here's why. The wow signal had all the hallmarks of a deliberate transmission from an advanced civilization. What caused the signal was a narrowband, an incredibly strong radio signal lasting a mere 72 seconds. Most celestial radio signals are broad and faint, whispers in the cosmic noise. The wow signal, however, was loud and clear, like a beacon cutting through the static. The signal also originated from the constellation Sagittarius, a direction devoid of any known natural phenomena that could produce such a signal. The wow signal has never been detected again. Despite repeated observations of the same region of space, the signal remains elusive. Was it a one-time message, a technological hiccup from an alien civilization, or a cosmic fluke mimicking an artificial signal? Space sure is a creepy place. Or maybe us humans are just scared of the unknown. What do you think? Share your opinions in the comment section below. If you want more videos just like this one, show some appreciation by giving us a huge thumbs up and subscribing to the channel. Catch you in the next one.